Greetings. This is Graham Warren working with you on the simulation model, the AnyLogic simulation model for the juice bar case. So on Canvas, you'll see that we have prepared models for a number of cases here, and the juice bar case is one of those. Now, to load this, I suggest first downloading AnyLogic and launching it. And once it's launched, then download that file and then open it up from the downloads within AnyLogic. So let's see how that's going to go. So it does take a while to load, and may as well, since this may be your first encounter with AnyLogic, just highlight a few things. So has been automatically saved. Yes, let's just replace that. Let's try that as well. I've been working on this previously. So on AnyLogic, there is the reason why it's been selected is because it has both Mac and Windows versions, and that's not true for some of the competitors, such as Simul8, that is SIMUL, and then the number 8.com, I think, and then FlexSim would be another. It is free for personal edition, which is a little basic. So when you let me just finish that thought. So free, both Mac and Windows versions, but the learning curve is a little steep, and we're sort of staying on top of this, from iteration of this course, from one iteration to another, instead of revisiting it. It is quite an ask to get going with AnyLogic, and with that in mind, we're providing pre-built models, and hopefully you're going to get a taste for what simulation can do, experimenting with some pre-built models. Okay, so AnyLogic is launched. The for-pay version is relatively expensive, but this one is free, and it does come with some commitments. For example, there's no Monte Carlo. There's no way to automate the iterations, multiple runs of a model, as far as I know. At least it was in the last time I checked. That wasn't possible in the free version. And then also, last time I checked, the free version is limited to generating 50,000 simulation entities. So, for example, 50,000 customers. So to get started here, I'm just going to go ahead and click out of the welcome screen there. I want to go back into Canvas and then just show you how I would download this. So go to the juice bar case. It's hosted on Google Drive, and we should be able to get a download here. And that's going to stick it in my downloads. I'm on a Windows box right now. And I'm going to go back into AnyLogic. This is some other model. And then I can just open in the downloads. There would be the juice bar model. Okay. So go ahead and hit that. And we can just say, they're identical, right? Because it's actually the same file. So I'm just going to close that and then just go in here, and you'll see that it'll populate somewhere down here. And you're looking for the juice bar model, and then you're looking for main. So I want to discuss, what this model is about in this clip, and then we'll come back in subsequent clip or two, and then look at our scenario analysis. So the best case, what happens if we train, if we put a juice spot in, and maybe if we pull. So it's trying to, this model is set up in a way that sort of allows us to analyze all of these different scenarios, a little generic from that perspective. So AnyLogic basically is a drag and drop tool. There's a palette here, and most of the tools that we're going to be using are in the so-called process modeling library. So what's happening in this model is I have what we call a source block. You can just drag and drop that, onto this so-called canvas, and it's going to generate customers at a certain rate. Now there's properties area for each of these blocks. And if I click on this guy, you can see what the properties of this guy are. It has arrivals that are generated at the rate of arrival rate, which is a parameter. What I'm using here are parameters, all the key quantities that are going to control, exactly what scenario we're in. So, for example, the base case, we're going to be analyzing just one of the humans. They have an arrival rate to them of 65 per hour. That's the customer arrival rate. Their service rate is, I believe, 90 per hour. And the standard deviation of their service times is 20 seconds in the base case. So those kinds of parameters, the service time mean, standard deviation, the number of human servers, number of juice bots, and so forth. These are all parameters that we can vary to sort of look at these different scenarios. So in the base case, arrival rate is going to be 65, and we will go and edit that here rather than going block by block. Try to make it a little bit more transparent, and it also shows up in the output so that when you run the model, you kind of know what your parameterization looks like. Okay, so we generate these customers, and then we start a timer. In fact, we start two timers, timer 1 and timer 2, because I'm going to be interested in how long does it take to start getting service, and then, so in other words, how long in the line, how long are you waiting for service, and then how long from time of arrival to drink in hand, essentially. I'm also interested in that. So timer 1 is measuring time in system, and time 2 is measuring just time in the line, waiting for service, but not yet receiving service. All right, so start these two timers, and then we join a line that is where we wait for a server. And the server could be one of two types, a human server or a juice bot. So if I click on this block here, you can see that I have resource sets, human servers and juice bots, and so I could make I could say that they're the way this works is it first looks for a human server, and then if there isn't a human server, it's going to go after a juice bot. So it has that sort of order. Now I could control how many human servers and juice bots there are in these so-called resource pools. If you scroll down here, you can see there's a resource pool right there. And these two blocks are resource pools. So that's the number of human servers. So let's have a look and see how many we have. Turns out that there are a number of human servers. So that's how I control how many humans are serving this arrival process. And then the same is true for the juice bots. So these are so-called resource pools. Okay, once they have lined up and eventually gotten a server, they kind of grab that server. The timer 1 ends because now we've figured out how long they were waiting for that server. That's their time in the line. And then the juice prep starts. So this is a delay. And you can see there's a delay block up here. And that delay is going to be, I need to change this. Let me just go in here. So if it's a human, if the human servers, so if it is a human server, I need to change this to service time standard deviation, and then the meantime is service time mean. So basically, the little Java equation in here, which we're not going to spend a whole lot of time looking at. But if there is, so these would be the human times, service time mean and service time distribution, standard deviation. If there is a human serving, then those would be the parameters used. If it's a juice bot, ultimately, then what I'm doing is I'm checking to see if there is, if it's a human server, and if it is, then I apply those times to the processing time of the drink, and if not, then it's 50 seconds, which is the time that a juice bot takes to serve. All right, after that, we end timer 1, which is measuring time in the system, and then we release that either that human server or the juice bot. It just releases the all possible resources, and then from there we go to a sink. So the sink is where these customers essentially are disposed of once they're done completing the process. We are going to get histograms on the time in the line. So the time in the line is measured using timer 2, and you can see that's timer 2 end. So I take this timer 2 end, and I'm just getting the distribution of that here. And then the time in the system comes off timer 1, also distribution. This timer 1 end is connected to timer 1 start by this statement here. So I have to specify, I've got a timer start, but I have to connect the timer end to the timer start just so that it knows how to sort of sync these guys up. Okay. And so ultimately what's going to happen here is I'm going to run this model. Customers are going to start, shooting through the system, getting, waiting for service by either a human or a juice bot, getting service, exiting, and we're going to collect statistics on them. And the key parameters, the arrival rate, the service time mean, service time standard deviation, and then the number of humans and juice bots that are available to serve our customers are going to be specified using these parameters. Okay, so I think in brief, that's our model. I'm going to run it immediately before we go into the scenario analysis, just so you get a feel for some of the issues here. There is a question, a few things that need to be done in simulation. One is you're going to have to run it multiple times. So replication is sort of an unavoidable part of simulation. If you run it one time and use the results, it's like showing up at this juice bar, on some random day, observing it, and then concluding that you know how the juice bar operates. That's just not going to be a representative look. So you're going to have to go back typically multiple days. Exactly how many would be dependent on the variability that you're seeing across the days. And if they're pretty uniform, then maybe 3 or 4 days would be fine, and you'd be done. And if it's very highly variable, you may have to do as many as 30 runs or look at the system on 30 different days to sort of get a better understanding of what to give a representative characterization of the operation. So I think those are easy to understand principles, but this idea that we need multiple runs is sort of exactly in line with that thought. We're also going to have to determine how long we're going to run this thing. Now, in our case, that's pretty easy to spell out. So we are able to generate 50,000 customers. I wanted to show you that I have limited us here to 49,999 right there. That's the maximum number of arrivals. So you can just slide this back there to see if that's the number that I'm specifying there as a parameter, because it's the hard limit of the free version. So I'm trying to figure out how long I'm going to be able to serve here. So if I have 50,000 customers, which is a software constraint, and if they're arriving at the rate of 65 per hour, right, then I can figure out how many hours I'm going to have. So let's just plug that in. I thought I had just end this here. Let's just get our calculator. There it is. So 50,000, let's try it again, 50,000 divided by 65. Doesn't look good. 50,000 divided by 65, 769 hours. I don't know what the units of this are, but if I multiply that by 60, that's 46,000 seconds. I'm just going to use 46,000. So to see what the units of this thing are, I go here and I just look at my simulation main. Yeah, here it is. And we can just slide along here, and should be in here somewhere. Okay, here are my parameters, incidentally. I'm able to adjust those there. Maybe it's in run configuration. Just click on that. Sorry, simulation main. No, run configuration. Model time animation, maybe it is in simulation main. Mm. So ordinarily, I am able to find this rather quickly. Not sure why that's a problem for me right now, but the units of my model, let's just try going to this top line. There it is, it's in seconds. So actually, I need to express I could change this to minutes, and then we'll just do it in minutes. So I'll go ahead and save this. And then I'm going to specify in run configuration, sorry, I think it's simulation main. There it is. What my parameters are for the run, and they lay it out here. No juice spots. So this is basically, looks like the base case. Go ahead and run this. So you basically run it through this little green arrow. It's going to give you error codes if there is an error. These things are tedious to debug. Can really test, your sort of hair pulling propensity. This one, is it running or not? I can't quite determine. Maybe I killed it. Okay, let's try it again. Okay, here it comes. And to set up the run length, I'm going to go in here where that little gear is. I click on these three little dots, and then I'm going to set this up to be 46,000 minutes of duration. You want it to show the 46,000 in red. And then the controls on this thing, see that there are some customers already running through. 9 customers have generated, 10 have started there. You can see 5 have now completed. Actually, this is another model. Let's just go in here. I need to run the juice bar. So because I have multiple models set up, here's the juice bar, and we should be able to get this to go now. All right, now confirming that I have the juice bar set up here. I want to set this up for 46,000 seconds of run length. There it is in red. You can control how fast this thing is going. You can see that 18 have grabbed the human server or the juice bot, whatever. I think there's just one human server in this particular simulation, and you can see how many have now completed the juice prep and released. You can speed this up using these controls here. You can see your speed 25 times, and you can see now the completions are going through pretty fast. You can slow it down here, go back and just watch and make sure that it's building correctly. So you can see the average time to in the line is about currently at 0.87 minutes to get the juice in hand from time of arrival to in hand. 1.5 minutes are like about 90 seconds. And then I'm going to go ahead and just flat out run it as fast as possible to get all the way through 50,000 customers roughly. And here it goes. And you can see it stopped at 49,999. My average service time was 176. So I'll repeat this for you in the next clip, but this is an early look at the ACG simulation model, and explained a few things about the blocks used to build this model. Most of our work is just going to be to set up our scenarios. By adjusting those parameters, we don't have to worry too much about connecting these blocks and debugging these models. But we're happy to talk about building these models if that's something you'd like to do. But to get the analysis to go, you're able to work with a pre-built model.